This is question 2 of the Natural Sciences Admissions Assessment Specimen paper. And in this question we have a right-angled triangle given here with this hypotenuse, and we know that the length of PQ is 20 centimetres, and we also have a ratio for the side lengths of RQ and PQ, which is 1 to 2. We want to know the length of the perpendicular from the hypotenuse to the point Q. I've labelled that on X. So what we're going to do for this question is we're going to consider this angle theta and try to get two expressions in terms of theta and x, which we can then solve simultaneously to find x. So the first thing to do is to find the length of RQ and PR. So why don't you have a go at doing that now? So the way to do this is to use the ratio that we've been given. So we're given that RQ to PQ is 1 to 2. And we know that PQ is 20 centimetres. So all we're doing from the 2 to the 20 is multiplying by 10. So we get that RQ must be 10 centimetres. So we've labelled that on there. And now we're going to use Pythagoras to find PR. So have a go at doing that now. Okay, so by Pythagoras, we square this side, add them together and square root to get this side, which is 10 root 5. Okay, so the next thing we're going to do is to consider this triangle here. This triangle has come from this triangle here. And the reason we're going to do this is because we know that this is a right-angled triangle because this line of length x meets PR at a right angle. So this is a right angle here. And so we can use what we know about right-angled triangles to get an equation for theta and x involving the 10 we've just worked out. So have a go at doing that now. So you should find that for this pink triangle here, we can just use a simple trigonometric identity. So we've just got that sine theta here is equal to the opposite side, x, divided by the hypotenuse, 10. So sine theta equals x over 10, which is nice and simple. So the other triangle we're going to consider is the big triangle, this whole thing here, which also has a right angle and also involves theta. So we have this triangle here. I've written on the 10 root 5, which we worked out, and the 10 that we worked out. So why don't you try and find an equation involving theta for this? Well, we have that sine theta, again, is equal to the opposite over the hypotenuse. So we get this equality. So we can solve this because we know that here sine theta is equal to x over 10, and here sine theta is equal to 20 over 10 root 5. So because we've got the same theta in each case, we can equate these two things. So x over 10 equals 20 over 10 root 5. And we can now solve for x to get that x is equal to 4 root 5. So our answer is E.